In this video, we'll be representing ratios or fractions as rectangles, and we can see how we can compare them on the coordinate plane. Check this out. A ratio is a relationship between two numbers, indicating how many times the first number relates to the second. The ratios are same as fractions. So if I say ratio, I can say fraction. Fraction is a ratio. Any ratio or fraction can be represented as a rectangle. The numerator and denominator will be the size or the side measures, side lengths of my rectangle. I'll have the vertical side on top. The vertical side will be my numerator, and the horizontal side will be my denominator on the bottom of the fraction. Eventually, we'll call them rise and run, and that will be connected to the next lessons, which will be about slope. So in the ratio, we have the numerator and denominator. Vertical side will be on the numerator, and the horizontal will be on the denominator. Check this out. We have fractions or ratios that always equal to 1. If I look at this squares, are they the same size? No, but their simplified ratio will be equal to 1. Let's see what that means. So the numerator and denominator has to be the same number vertical and same number horizontal. If I simplify same by same, I always get a 1. Same rise, same run. In this square right here, the size is 1 by 1. So if I was to write the fraction, that would be 1 over 1. This square, I have size 2 by 2. If I write it as a fraction, 2 over 2 simplifies 2 divided by 2 to 1. Look at this square. I have 3 by 3. So I have 3 vertically, 3 horizontally. 3 over 3 in the fraction. What is 3 divided by 3? 1. So in the square, if I represent the ratio 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, in the fraction 5 over 5 will be 1. So every square has the same ratio, 1. Let's see my next one. 1, 2, 3, 4, 5, 6, 7 vertically. 1, 2, 3, 4, 5, 6, 7 horizontally. If I use the same vertical number over same horizontal number in the fraction, that is 7 over 7. And what is 7 divided by 7? 1. Let's see how that looks like on the coordinate plane. So if I was to plot on the coordinate plane, on my x-axis, I'm going to have my horizontal number, and on the y-axis, I'm going to have my vertical number. So for the square 1, 1, I'm going to go 1 by 1. That 1, 1 square, 1 by 1, then I have the square 2 by 2. So I'm going to go from the origin 2 by 2, and that will be the square. So it's like I'm going to overlap them all together and just put each square that I have here onto the coordinate plane and just like stacking them on top of each other. Then I have 3 over 3, so I'm going to go 3 by 3, and the bigger the squares get, I want to make them nice and neat, so I'm going to stay away from freehand and use a ruler. So 3 by 3. Then I had the square here 5 by 5, so I'm going to go from here to here, so 5 by 5. I'm drawing the size of the square. onto the same coordinate plane here. So I had my 5 by 5. And then I had the 7 and 7 side measures. So I'm going to go across to 7. And 7. So once I have them all stacked together, and I look at their corners, so this one, and 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 I connect them going through the opposite corner from the origin, and I put a ruler, I'm going to go straight through every single corner. And that is what my 1 is. That is a line that is represented by that ratio of 1, showing that it is a tilt. So every square has a diagonal, and that diagonal in each square equals 1. So if I draw a diagonal and I say, what is the inclination of this diagonal? In each diagonal, we have the same exact inclination. You can even see that these lines are all parallel to each other if I was to extend them. If I overlap my squares, diagonal crosses all my squares. And now, if I look through corner to corner, this diagonal is just 1 unit. If I go from corner to corner on 2, I start with 1 corner and then I go diagonally, 1 diagonal, and then 1 by 1 second. If I start in this corner, I have 1 diagonal, 2, 3 counts diagonally, and they are made of 1 square, so 1 by 1, 1 by 1. Then if I go from opposite corner diagonally, I can connect 5 units or 5 little squares across my diagonal, and they will be 1 by 1. And then from the last one, from the corner, I go diagonally, 1 by 1 little square, then diagonally it's going to be another one, 1 by 1, 1 by 1, 1 by 1, 1 by 1, and they will be 7 total if I was to go 1, 2, 3, 4, 5, 6, 7. So all those diagonals have the same inclination, and that will be unit or the ratio of 1. They all have the same tilt. Let's see a different type of a ratio. In a proper fraction, proper fractions are always smaller than 1. When we see proper fractions, they're like 1/2 or 3/4 or 5/7. The numerator is always smaller number and then the denominator is bigger. So small rise, big run. Vertical line will be smaller and the horizontal is bigger. So I have a rectangle here, 1 and then a cross 4. So that would be 1 by 4. In the fraction, where I put the vertical number on top, horizontal on the bottom. Second rectangle has 2 down across 3. So the side 2 vertically over 3 in the ratio. So in the ratio, we are going to put the vertical on the numerator. So the numerator is vertical 2, and the horizontal is the run, or in this situation, the number 3. Now let's see this one. 1, 2, 3 down. And then 1, 2, 3, 4, 5, 6, 7, 8 across. So in the ratio, that would be 3/8. And that's a proper fraction because the numerator is smaller. 1, 2, 3, 4, and across 1, 2, 3, 4, 5. In the fraction, that will be 4/5. And then we said all the proper fractions are less than 1. So what does that mean? That means that if I simplify or change these fractions to decimals, I will have all the answers less than 1. So those are the proper fractions. So for example, 1 divided by 4, that's our quarter, 0.25. So I'm going to say this is 0.25. Then I have 2/3. 2 divided by 3, 0.6, 0.7 if I round it, 0.66666. So you can round it up to 0.7. This one has to be 0 point something too, because all the proper fractions have to have a decimal equivalent less than 1. They're all less than 1. And you see how all the rectangles are kind of squished? So 3/8. 3 divided by 8 is 0.3 with a 7 after. We'll round it up to 0.4. And then 4/5. 4 divided by 5 is 0.8. 0.8, 0.4, 0.7, 0.2, just 25 our quarter. So all the proper fractions are less than 1. That's what it means here. Let's put these rectangles on the coordinate plane and we'll see that. Check this out. All those rectangles are going to be less than 1. So they have to be lines that after we connect the diagonal, lower than this 1. So what I'm going to do first, I'm going to use from the origin the diagonal that equals 1. So that means 1 across 1 over 1 on 1, 1, making little steps or going across diagonally 1 by 1. And I'm going to highlight that line in yellow. And I'm going to say this is my unit line. Then all the proper fractions or all the proper ratios here that I'm going to use are going to be less than 1. So they have to be below this line. Well, let's test this and see if that's true. So the rectangle 1/4, so it was 1 by 4. Was my first rectangle here. And if I go from the origin and connect the diagonal, I'm going to make a nice line here, extend it, make sure that I write 1/4 on it, just so I know that that was my rectangle with the ratio 1 by 4 or the size measures. And then I'm going to have 2/3, so it's 2 by 3, 2 vertically, 3 horizontally. So 2 by 3 rectangle. And then right away, I'm going to connect from 0 diagonally and extend, put an arrow on it and say this is my ratio 2/3. Then I had 3/8, so 3 vertically, 8 horizontally. So that is my long rectangle there. That was 3/8. So what I'm doing is I'm overlapping those rectangles. Then I go through corner to corner and extend and put an arrow on it and label it 3/8. In other words, that was my ratio that I traced. And then I have one more 4/5. So I have to go vertically from the origin 4 and then 5th. So the size of the rectangle was 4 by 5. 4 up, 5 across. 4 vertical, 5 horizontal. And that's the corner that I'm going to connect corner to corner, go diagonally and extend. Right away put an arrow on it and label it 4/5. So you can see that all my rectangles are below 1. In other words, all those values are less than 1. And what that does is helps us compare fractions or actually put them in order from least to greatest. I can even say my decimal equivalents here. Quarter was 0.25, then my 3/8 was 0.4, then my 2/3 was 0.7, and then my 4/5 was 0.8. So you can see how from the bottom up we have our order 0.25 and then higher 0.4, then higher 0.7, then higher 0.8, and then the highest is the fraction that was 1. So if I have a lot of fractions to compare, I can always put them on the coordinate plane, representing them as the rectangles, and then they come up in order for me just like that. And if I have to place my ratios in order least to greatest, I'm going to start with 1/4 is the smallest value, then 3/8, then 2/3, and then 4/5. So just pick up your answers from the bottom up. Let's see improper fractions. When we have improper fractions, you can see that the rectangles are all tall, and what makes them tall is the bigger number on the numerator and smaller on the denominator. So in improper fractions, we have values greater than 1. That means the bigger number on top and smaller on the bottom. When you divide, you're going to be bigger than 1 values. So the first one, I have 2/1. In the ratio, that's 2/1. If I divide 2/1, that's just 2. Next rectangle is 3/1. In the ratio, 3/1. When we simplify, 3 divided by 1 is 3. So that's more than 1. This one has 4, 1, 2, 3, 4. So 4 vertically, 3 horizontally. In the ratio, that's 4/3. And if I was to divide 4/3, that would be 1 1/3. So 4 divided by 3. 1 1/3, so 1.3 if I want to just transfer or convert to decimal with the line above. Then I have the next rectangle. 1, 2, 3, 4, 5, 6, 7 vertically. 1, 2, 3, 4 horizontally. So 7/4. 7/4 vertical on top over horizontal. 7/4. That value has to be bigger than 1. So if I divide 7 by 4, fraction means division, that is 1 3/4, or 1.75. So I can use a calculator. So in a calculator, 7 goes first. So 7, then we divide, fraction means division, by 4, 1.75. Oh, this one is a tall one. 1, 2, 3, 4, 5, 6, 7, 8, 9/2. In the fraction, 9/2 is a 4.5 or 4.5 decimal equivalent, 9 divided by 2. And this one we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6/5. Well, 6/5, if I divide, it is 1 1/5, or as a decimal equivalent, we have 1.2. So all improper fractions have to be values greater than 1, bigger than 1. So that is tall rectangles. Let's draw them on the coordinate plane. And that line that equals 1, so from the origin, I go diagonally. 1 point, 1 point, 1 diagonal, 1 up, 1 across, 1 up, 1 across. Place a point and just keep going. I'll mark it 1. So that is my unit ratio, 1 by 1, where all the squares were before. Now we're going to draw the rectangles that represent improper fractions. So the taller numerator. So I have the first rectangle 2 by 1. So 2 up, 1 across. And that one, where's my orange here? Right away, connect the diagonal from the origin, go through and keep going and label it 2 over 1, or just 2, because 2 divided by 1 is 2. Next one was 3 over 1. So 3 is the side measure by 1. And I have this corner right here, so I'm going to place my ruler, connecting the origin, and then going through the diagonal that was the measure for this rectangle, and say that was my 3 over 1. Then I have 4/3. So 4 is the height, and then up to 3, 4 by 3. So I'm going to draw it as I have it here. 4 vertically, 3 horizontally, and this is the point diagonally that I'm going to connect and go through the origin, extend, and mark that that was my 4/3. Then I have 7/4, so it's 7 units high and 4 wide. So I'm gonna have right here at the point of intersection and use a ruler because it's very tall and I want to make it nice and neat and not just use freehand. Try to use your rulers as well. And the point on the diagonal right here, I'm going to connect through the origin, extend it, put an arrow on it, and say this is my 7/4. And then I have 9 over 2. So 9 is the height, or how tall it is, and then up here I have the size 2 for the rectangle 9 by 2, which is really tall, and the value is 4.5, so it has to be the highest value. See how tall it is, and it passes all the other lines. So that's 9 by 2. And then I have one more 6/5. So from 6 on this side and 5 on this side, I have the 6 measure on this rise or vertical and 5 horizontal. So I go horizontally 5 units, vertically 6 units, and that completes my rectangle. That it was 6 down, 5 side to side. And that is the corner right here. And I'll connect that diagonally. And once I have it, I'm going to put 6/5 label just so I remember which is which. So all my whole or improper fractions have bigger than one value. You see how all those diagonals are above one? And now you can just pick them up and put them in order, starting with the lowest after one, going high, 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 up to 9/2, which shows as the highest value. So check this out. If I have to place all these ratios in order, least to greatest, I'm going to start with 6/5. So that is the lowest value. And after that, I have 4/3 and at 7/4, and then 2/1 or 2, and then 3/1, and then 9/2. And if I use their decimal equivalents, 6/5 was 1.2, then 4/3 was 1.3 ongoing, then 7/4 was 1.75, 1 3/4. Then we have the value of 2, which is 2/1. Then we have the value of 3, which is 3/1. And then we have the 9.2, which is 9/2 ratio, which is 4.5. So if you look at the decimal equivalents, we have 1.2, 1.3, 1.75, 2, 3, 4.5, and you can see that they're all bigger than one, and they just get taller, 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 and higher tilt as we go on. So this is a way of representing ratios as rectangles, comparing those ratios on the coordinate plane, and placing them in order least to greatest.